So I think last class I have discussed open feed water heater system. So it is a simple system if you are observing. Only the single heater is used here. It is a open feed water heater type. So directly mix or a direct contact type of heater. So at the end of that heat exchange process, that feed water will attain the temperature up to the saturation liquid. And here we have written some equation. So that is the energy balance equation. Perhaps you have remembered this one. So only M1 amount of steam is bleed from the turbine. So this is your energy balance equation, from where we can find out what is the M1. Then we have found the heat addition process. Then it is the equation for the heat rejection. We can also find out what is the turbine work. So in this case, your turbine work will be, the turbine work will be your how much it is the, so it will be the H1 minus H2 plus it is your 1 minus M1 into your H2 minus H3. So this is your turbine work. H1 minus H2 plus 1 minus M1 H2 minus H3. So similarly, we can write down what is the pump work. So pump work is in this case is your if you are observing here, it is a two pump is used. One is after the condenser, and another one is after the open feed water heater. Okay, so this one is the pump one, and pump another one is the pump two. So if you are observing in this case, the pump work will be done at the 4 and 5 and 7 and 6. So I can write down what is the pump work in this case. So pump work will be here the amount of steam is entering to the pump is a 1 minus M1 amount, and in this case it is the we are considering it is the generally S7 and S3, that is the 1. So let me okay. So this will be the H7 minus X6 plus 1 minus M1 H5 minus H4. So this is your pump work. So from here we can find out what is the network output. So network output will be the WT minus WP, and we have already the equation, that is the WT and WP. Also we can find out the M1 amount of steam from this energy balance equation. So then we will get the W net. So then we can write down the what is the efficiency of the cycle. So that is your 1 minus Q out upon your Q in. So Q out means that is your Q2, and Q in means your Q out. From this relation we can get what is the efficiency of the regenerative cycle. So the in case of the regenerative cycle, what we are doing, we are reducing the heat consumption. And heat consumption means in that case that feed water which is entering into the boiler, we are increasing some temperature, so that the heat addition at this process will be at the min temperature, and that is the maximum amount of heat addition, where it will affect the efficiency of the cycle. So thermal efficiency will improve, because in this case we are minimizing the fuel supply to the furnace. And but the drawback is that here in this case um, your work output will be reduced. So work output is less in case of the turbine. So this is the turbine. In this case, specific work output will be reduced. To achieve that specific work output, we have to give more steam into the turbine. But so whatever the output we are getting in this regenerative cycle, that is more than the simple runtime cycle. Okay, so that's why it is preferable one, because in this case we are getting the more efficiency, and as well as the specific output of the turbine will be little bit higher than that of the simple runtime cycle. So it is the direct contactor. Then we are discussing here. It is the two-stage type of feed water heater heating process. So here you have doubt in previous whatever the classes I have discussed to you. So please see the picture in this case. So this one is a boiler. So from the boiler to turbine, there is a 1 kg of the steam is entering to the turbine. So from the turbine, we have shown it that intermediate of the expansion process, the steam is bleed from the turbine. So at the point two, there is a M1 kg of steam is bleed, and at point three, that is the M2 kg of the steam. So M1 kg of steam is utilized in this heater 1, and this one is the heater 2. Okay, either you can take it is a heater 1 or heater 2. Mm, mm, Then at the outlet of the turbine, we are getting the steam after the expansion will be 1 minus M1 minus M2. Okay, because M1 is removed, M2 is removed. So from the 1 kg of steam, we have the this much of the theoretical steam, which is mm, which we are getting at the outlet of the turbine. So that will send to the condenser. So at the outlet of the condenser, here we are assuming the same amount of steam is formed into the condensate without any piping losses. Without any losses, we are considering. So here that amount of condensate will form to the heater H1 or H2, whatever maybe you can take. So if it is the H1, so in this case, this amount of condensate will enter, and it will leave from the heater. Um, so that amount is here we will have the M2, so it will get added with this one. Then here we will get the 1 minus M1 amount of condensate. Okay, so here the heat exchange process will achieve, so that condensate will get some heat from this heater 1, and that temperature of the condensate will increase to the uh, if you will see here. So this one is the in case of the 1 to 2, there is the 1 kg, and 2 to 3, that is the 1 minus M1 kg, and 3 to 4, that is the 1 minus M1 minus M2 kg. So which we have shown in this case. We have 3 to 4 before the condenser. We have um, um, 1 to 2, then 2 to 3. Okay. So 1 to 2 में expansion हो रही है, then 2 to 3 expansion हो रही है. So that one is here. 1 to 2 is 1 kg था, फिर 2 to 3 में 1 minus 1 kg हुआ, 3 to 4 में 1 minus M1 minus M2 kg. Okay, so here if you are observing, so this is the diagram. If you observe, then we will discuss the TS plot. So after that, 1 minus M1 kg of condensate will go to that second heater. So here it will get the M1 kg of the steam. So here it will get added, means 1 minus M1 plus M1, so that will become 1. So here at the outlet, 1 kg of steam or feed water, or sorry, it is not the steam, so it is a saturated liquid water which will be pumped to the boiler. Okay, so here the temperature will also increase due to the exchange of heat in this heater. Okay, so this one is the two-stage feed water heating process. So modern power plant, there we are using the three stage of feed water heating process, and there we are using the both the combination of the cycle, that is the reheat and regenerative cycle. So if you have remembered, we have studied already the reheat cycle. So reheat cycle means there we are mainly focusing the increase of the work output or turbine specific power output. So in that case, two stage of expansion process we were following. In case of the regenerative cycle, here what we are doing, we are reducing the fuel consumption, and so indirectly we are increasing the thermal efficiency, right? So if you are using the both the combination, in that case what will happen, your specific power output will increase, and your regenerative cycle means your thermal efficiency will increase. So overall efficiency of the plant will increase by using these two methods. So which will I will discuss in later stage. So here I have shown only the two-stage feed water heating process, and how that energy balance equation will use to find out that M1 amount of steam and M2 amount of steam, that we are going to find out, and what will be the turbine work in this case, regenerative cycle, and that one also we'll discuss, and what will be the pump work. As I have already told you, in case of the regenerative cycle, you will have some specific power output losses, so that one also turbine work losses, that one also we will find out. Okay, so here it is shown, it is the loss in work output, so that one we will also find out in this case. Okay, so I think this diagram is clear to you. So here the steam from the turbine will enter to the condenser. This amount of condensate will form. It is a theoretical process, ideal process, so that's why we are not considering any losses. So then it will form to this heater. So there it will exchange with the heat steam, and here it will come to the 1 minus m1. Then it will go to the again this heater. So here 1 kg of the feed water will enter to the boiler, right? So here we have used a three pump. So there we can see the different point in this case. So first one, and this one is the point 5 to 6. At the 5 to 6, if you are observing, it is the 5 to 6. Then we are having the 7 to 8, then 9 to 10. 7 to 8, 7 to 8, and 9 to 10, right? So this is the pump work to achieve that boiler pressure or intermediate pressure. So here it is the boiler pressure P1, and it is the condenser pressure P4, and in between these two it is the intermediate pressure. This one is the P2 pressure and P3 pressure. Got it? So if you are observing in this case, here one amount of steam is run, then it is here it is the heat exchange process. It the here 1 minus m1 amount of mm, steam is entering, or fluid is entering to this phase, and it will mix with your steam, and here 1 kg of uh, uh, feed water will pump to the boiler. So this is the 1 kg of the feed water. So similarly, what I have explained here, similarly, it is applicable to this process also. That means here 1 minus m1 minus m2 amount of steam is um, drawn at this point. So here there will be the heat loss. So let us take it is the heat loss is your Q2. But here in this case, the condensate will be achieved to the saturated liquid state. Then it will pump with the help of the pump 1, 5 to 6, and it will gain the temperature up to the saturated liquid by exchanging this heat, and then there will be the uh, continuous process. Again it will pump like that, it will continue. Okay, so this is the regenerative cycle. So here if you are observing this diagram, So let me explain first, then I will write down the individual equation. So if you are observing in this case, it is the first stage of expansion in case of the 1 to 2 in turbine point, that is the 1 to 2, then 2 to 2 dash will be the this amount of here 2 2 dash means it is the heat released by the steam condensing from 2 to 2 dash. Okay, so that will be utilized to gain the heat exchange at this process 8 to 9. Okay, 8 to 9. ओके, इन दिस केस ओके हीट एक्सचेंज हुआ तो 8 to 9 प्रोसेस में आप 2 to 2 days का जो हीट लॉस हो रही है यहाँ पे हीट ऐड हो रही है, हीट इज यूटिलाइज टू अचीव द point or water temperature from 8 to 9. So similarly in this case 3 to 3 dash or 3 dash to, so this is the 3 dash to 3 dash, this amount of heat is lost to increase the temperature of this one. Okay, so so likewise so if you will observe in this case your expansion process will be in the step format, so like this expansion will achieve. So this amount of work is lost if we are drawing the some amount of heat from that turbine. Okay, so this is the loss in work output. Got my point? So in the form of the equation we will find out later on. So first let me write down what will be the turbine work in this case, then what will be the pump work in this case, and what will be the cycle efficiency. Then we are going to write down what is the steam rate. So first one is your turbine work output. So let me find out this one. Turbine work output means first here there will be the expansion, here 1 kg of steam is utilized. So 1 to 2, that point is H1 minus H2. Okay, so here I will multiply 1, then plus 2 to 3 expansion process means here the fluid is utilized 1 minus M1 fluid into H2 minus H3, right? So similarly in this case we expansion point will be H3 minus H4. So in this case the amount of fluid is utilized 1 minus M1 minus M2 into H3 minus H4, right? So this is your turbine work. Then we can also find out what is the pump work. So pump work is at this point and at this point and at the process. So 3 point is utilized for the turbine work. That is your, here it is the WP1, WP2 and WP3. So WP1, WP2 and WP3. So the points are 5 and 6, 7 and 8 and 9 and 10, right? So let me write down that equation. So first WP1 means in that point is 5 to 6. So here the fluid that is the condensate will be how much amount? So that amount is 1 minus M1 minus M2. ओके, सो ये कंडेंसेट यहाँ पे पंप हो रही है 5 and 6 में. सिमिलरली 7 and 8 में क्या हो रही है? 1 minus M1, right? So similarly in this case 9 to 10, here 1 kg of the feed water is pumped to the boiler pressure. Okay, pumped to the boiler pressure, right?
मैम
So यहाँ पे oh
मैम यहाँ पॉइंट पॉइंट टू पॉइंट थ्री पॉइंट फोर पे सेल्फी जो
the voice is breaking.
सेम अलग अलग होती है.
Okay, please tell me.
मैम यहाँ पॉइंट टू पॉइंट थ्री और पॉइंट फोर पे इंथैल्पी जो होगी वो अलग अलग होगी या सेम होगी?
अलग अलग होगी एंथैल्पी.
ओके मैम.
है ना, हर एक पॉइंट में अलग अलग होगी. H2 में आपका P2 प्रेशर में होगा, H3 में आपका P3 प्रेशर में होगा. ठीक है, ये जो आप एंथैल्पी फाइंड आउट करोगे ना 2 में, राइट? H2, so that will be at P2 pressure and H3
ओके मैम.
will be at the P3 pressure. Okay,
यस
so I think I have written it here. P3 है यहाँ पे लिखा हुआ है, so this one is the P2 pressure. Got my point? So the pump will be pump the condensate to the pressure. ये यहाँ पे P2 प्रेशर में पंप करेगी, यहाँ पे P3 प्रेशर में पंप करेगी. ठीक है, ठीक है ना? Yeah,
Yes.
this pump will utilize to pump the condensate or feed water to the heater pressure. That pressure will be the P3 pressure. Then again it is pumped to this pressure. So this one is the line, right? ये P2 pressure है ना. तो आप ये जो एंथैल्पी सब फाइंड आउट करोगे, ये पॉइंट में और ये पॉइंट में, वो P2 प्रेशर में होगा. तो यहाँ पे अगर फाइंड आउट करेंगे ये P1 प्रेशर में होगा. ठीक है. So now let me write down what is the WP. WP means first I will write down for the pump 1. So the pump 1 is in this case your point is your 5 and 6 and the condensate is your 1 minus M1 minus M2. So your pump work will be how much? 1 minus M1 minus M2 multiplied with your H5 that will be the H6 minus H5. Similarly, in this case, the fluid will be the 1 minus M1 and the pump enthalpy will be the H8 minus H7. So that will be the 1 minus M1 multiplied with H8 minus H7 plus there will be the another pressure, that is the P1 pressure in this case. So the pump will be utilized to achieve that pressure, the boiler pressure P1. So here it is the pump work will be from 9 to 10. The point will be from the 9 to 10. So enthalpy in this case will be the H enthalpy change will be in this case will be H10 minus H9. So the mass will be 1 kg. So it is your H10 minus H9. Okay, so this one is your pump oil. Let us give the equation name 1 and it is the 2. Okay, so then that heat addition is your Q1 is how much? So Q1 will be added uh, from from this point to this point. So here heat will be, the fuel consumption will be there. So heat addition will be from the from H10 to H1. It is done in the boiler pressure. So the Q1 I can write down, that is your H1 minus H2. The fluid mass is your 1 kg. Okay, so if you are observing, this is the mean temperature of heat addition. So here I have taken the dry saturated vapor or saturated vapor. So if you are taking the superheated, then the graph will be like this, and continuously there will be the fall of the fluid to the condenser pressure. So you can also plot that temperature entropy diagram. Okay, so this is the heat addition. So then there will be the heat rejection. Heat rejection will be at this point, right? So the point is your 4 to 5. Okay, got my point. So the 4 to 5 will be the heat rejection. So I can write down that fluid is your 1, condensate is your 1 minus M1 minus M2 multiplied with H4 minus H5. So this is the heat rejection. So then we can find out what is the cycle efficiency. So cycle efficiency is your Q1 minus Q2 upon your Q1. So which will be also equal to net work output upon your heat addition, that is your Q1. Okay, so steam rate is formula is your steam rate formula is that is your ratio of 3600 upon WT minus WP, right? So that is your steam rate. So in this case, if we'll correlate that your mean temperature of heat addition without regeneration with regeneration will be Tm1 with regeneration. concentration will be how much in this case? So here it is the H1 minus H10, right? H1 minus H10. So here entropy we are considering, that is your S1 minus S10. So that is your um, mean temperature with regeneration. So similarly T1 without regeneration will be um, okay. So this will be the H1 minus H4, H1 minus H4. This will be S1 minus S4. So if you are comparing these two, so here we can conclude that this mean temperature of heat addition will be more as compared to the without generations. As I have already told you that the efficiency of the cycle will depend upon it is a function of the mean temperature. So perhaps you have remembered that equation which we have already discussed. So this one is the mean temperature of the heat addition. So if you are observing that efficiency of Rankine cycle will depend upon the mean temperature of heat addition. So that Rankine cycle efficiency will be equal to 1 minus T2 upon Tm1, right? So here we have drawn that diagram. So if you are observing in this case, that mean temperature of heat addition without regeneration, that will be 5 to 6 in this case. Hmm. So 5 to 6 of, means that is the विदाउट जनरेशन मीन्स आपका यहाँ पे जनरेशन में हो रही है, तो यहाँ पे आपका विदाउट जनरेशन में होगी. ओके, और सिंपली यू कैन राइट इट एज द H1 minus H4. So in this case with generation that will be increased and this will be less. So efficiency will be more in case of the by using the with generation cycle. So next we will write down our energy balance equation, and then we can find out what is the M1 and M2. Okay, so let me first write down for the heater 1. Okay, so let us take it one. This one is the heater 1 and this one is your heater 2. Okay, so first here what will happen, so it is the inlet to the heater, here it is also inlet to the heater, and it is the outlet from the heater. Okay, the point 7, it's the outlet from the heater, and here it is the this point, that is, it is the point. So here it is the H3, right? Okay. So H3 means in this case, first let me write down the first equation. This is the heater one. So condensate will enter, that is the 1 minus M1 minus M2 amount, and here it is the M2. Okay. So M2 H3, the point is your H3, right? ये 3 पॉइंट है, यहाँ पे आपका H3 होगा, and this one is your H6 point. The fluid will enter amount is your 1 minus M1 minus M2, है ना? तो यहाँ पे आपका आउटलेट है 7, तो ये मिक्स होने के बाद यहाँ पे कितना फ्लूइड फ्लो करेगी, यहाँ पे आपका फ्लो करेगी 1 माइनस M1, राइट? तो फर्स्ट हीटर के लिए आपका एनर्जी बैलेंस इक्वेशन विल बी your inlet will be the H3 point, H3. Okay, so the mass of steam will be entered M2 plus inlet another point is H6. यहाँ पे H6 हो रही है, फ्लूइड कितना अमाउंट ऑफ एंटर हो रही है 1 माइनस M1 माइनस M2, ठीक है, प्लस आपका 1 माइनस M1 माइनस M2. The point of entry is your H6, which is equal to your at the outlet. So that is your outlet में कितना है, यहाँ पे 1 minus M1 हो जाएगा, right? So 1 minus M1 multiplied with your H7. The point is H7. So from this equation, we can find out what is your M2. So M2 को आप यहाँ से find out कर सकते हैं, ये portion आप कीजिएगा, और let me remove the so M1 and M2. H3 minus H6. Okay, so
Ma'am, this is heater or heat exchanger?
it is one type of heat exchanger. M2 H3 minus H6. So this will be 1 minus M1 H7 minus H6. Okay, so M2 will be equal to your 1 minus M1 H7 minus H6 upon your H3 minus H6, right? So from this equation we can get that what is the M2 amount of steam which is drawn for the turbine at the point 3. Okay, so now again we have to write out what will be the energy balance equation for heater, heater 2. Okay, so in this case the point will be at this point. So here what will be the equation, this is the inlet and this is the outlet. So 1 minus M1 amount of fluid will pumped at the point 8, so which will enter to the heater 2. M1 amount of steam is bleed from the turbine, which will be mixed with that one, and that will be become 1 kg of the feed water or condensate will be, which will be flow out from this heater 2. तो यहाँ पे आपका 1 kg हो जाएगा, ये 1 kg सर्कुलेट हो जाएगी बॉयलर में, है ना, पंप होके. So that energy balance equation if we are writing, then it will be the M1 into H2 and plus here it will be the H8 point. So here it is 1 minus M1 into H8 is equal to your H9. Okay, so this is for the heater 2. So equation will be the M1 into M1 H2 plus 1 minus H, 1 minus M1 into your H8, 1 into H9. Okay, so from this equation we can get what is the M1. M1 will be here, it is the H9 minus H8 upon here H2 minus H8. Okay, so this will be the formula to find out your M1 amount of steam. So this M1 and M2, this can also be find out by taking the energy balance equation or steady flow energy equation. Sorry, energy balance equation. So that equation I can write down, that is your ये वाला को M1 M2 को हम इसे और एक इक्वेशन से भी फाइंड आउट कर सकते हैं. Energy gain of feed water is equal to your energy given off by vapor in condensation. Okay, so if you are using this formula, then energy gain of the feed water will be how much in case of the your heater 2. So energy gain will be if you are observing, it is heater 2 case. So यहाँ पे आपका 1 minus m1 amount of steam use हो रही है यहाँ पे heat करने के लिए. So that will be energy gain of the feed water. The amount will be 1 minus m1 multiplied with h9 minus h8. Okay. So then energy given of by the vapor in condensation. ये condensation process यहाँ पे यहाँ हो रही है, राइट. तो यहाँ पे क्या होगा, कंडेंसेशन में मल्टीप्लाई होगा आपका m1 into your h2 minus h9. So here it will be the condensation process will be from 2 to 29. So like this we can write another equation also, from where we can find out the m1 mass of steam. So first case में heater 2 में आपका क्या होगा, that equation will be 1 minus m1. ये आपका एनर्जी gain of feed water H8, which is equal to your m1 H2 minus H9. Okay, so similarly आप यहाँ पे दूसरा वाला लिख सकते हैं. यहाँ पे कितना हो रही है, दिस अमाउंट ऑफ energy which is here that will be heated by using this amount of fluid. So this is your energy gain of the feed water from your 6 to 7 point है. तो यहाँ पे आपका energy gain by the feed water will be how much, 1 minus m1 minus m2 h7 minus h6. Okay, which is equal to your condensation में कितना heat loss हो रही है vapor condensation में. तो यहाँ पे आपका क्या होगा, m2, ये पॉइंट है h3, ये है आपका h7. ओके, ये फॉर्मूला से भी आप h2 m2 फाइंड आउट कर सकते हैं. आई कैन राइट इट इज 1 minus m1 minus m2 which is multiplied with your it is in a process, that is h7 minus h6, which is equal to your m2 h3 minus h7. Okay, so from this equation also you can find out what will be the m1 and m2. Now we have to find out what will be the heat losses or turbine work losses when it is that some amount of steam is utilized to heat the feed water. Okay, so so in this case, if you are observing from the diagram, so here in this case, this one is the heat rejection process, right? Q2 is your heat rejection process. So in this case, by using this regenerative cycle, your heat rejection will be reduced from this H4 minus H5 to the H4 dash minus H5. यहाँ से यहाँ आपका representation actual regenerative cycle नहीं रहने से you will have the heat rejection process will be that is your H4 minus H1 by but by using this regenerative cycle you can see that that will be reduced to H4 dash minus H uh, H H5. Okay, so here if we are considering the work output by this method, then in this case we will suppose we are considering the area under this diagram. Okay, area under this diagram will be the work output. Okay, so in this case if we are considering this one, this will be the loss in work output. uh, the amount I can write down output by amount if you are considering that area, then this will be in actual case that should be the 1 to 4. Okay, directly if you are considering 1 kg of steam is flowing inside this one, so that amount will be uh, directly from the 1 to 4. But in this case there will be the we are drawing the certain amount of the steam. So in this case the area under this curve, that is a 2 to 2 days, because this amount of heat is utilized to increase the temperature of the feed water, that is 8 to 9. ये हीट लॉस, इतना हीट लॉस हम यूज कर रहे हैं, सो दैट मीन्स ये आपका इतना अमाउंट ऑफ यहाँ पे हम स्टीम अगर यूटिलाइज करें तो आपका वर्क लॉस इतना हो रही है, एक्चुअल में इतना होना चाहिए था, ये लॉस हो रही है. The area under this one will be the 2 dash plus area under this one will be how much? It is the 3 double dash and it is 3 dash. Okay, so this will be the area under this will be 3 dash to 3 double dash minus your this one. So this amount of loss in work output we will get. तो ये आपको ये जितना हैच पर्सन हुआ है ये पर्सन आपको एरिया अंडर द कर्व से मिल जाएगी. सो वी कैन राइट दैट वन एरिया. So area under 2 dash means this is the work output, right? By this area or expansion process. Area under 3 dash minus 3 double dash minus this minus this will be the area under 4 to 4 dash. Okay, so this will be the loss in work output by amount we can find out from that area under the curve formula. Okay, so also we can find out from the equation. So for that one, let me write down that turbine work output. So that is your formula is this much. It is your 1 H1 minus H2, 1 minus M1, H2 minus H3 plus 1 minus M1 minus M2, H3 minus H4. So let me write it down again. Give the equation name here. Equation 3, 4, 5. This is the 6, 7, 8, 9. Okay. So first equation, if I'm writing, that is the 1 minus H1 minus H2. So simply I will write it down, 1 minus H1 minus H1 minus H2 plus your 1 minus m1 h2 minus h3 plus 1 minus m1 minus m2, it is your h3 minus h4, right? Okay, so this I can write it again in the form of uh, this 2 dash and 3 dash and 3 dash and 4 dash. So let me write down that equation. So expansion is done at this point and at this point, right? So instead of these 2, 2 and 3, so here it is having 2 dash to 3 dash and 3 double dash to 4 dash है ना. इसको हम और एक हिसाब से भी लिख सकते हैं, वो यहाँ पे है, where I can write that 1 minus m1 h2 minus h3 will be how much? It is your um, actual expansion will be. So here the m1, this amount of fluid is utilized, so heat loss is there by your heater with the help of the heater too. So in this case, the expansion will become it is the H2 dash minus H3 dash. Okay, so this is your H2 dash minus H3 dash. Okay, इसको हम ऐसे भी लिख सकते हैं. So this is the suppose 1 kg of steam is entering. Okay, in this cycle, continuous cycle, यहाँ पे अगर इतना 1 kg को हम consider कर रहे हैं, so it will be 1 into h2 dash minus h3 dash. So similarly, for the second one, I can write down 1 minus m1 minus m2, so which is the h3 minus h4, which is equal to 1 multiplied with it is the h3 double dash minus h4, right? So the expansion will be at this point. So here we are considering that 1 kg of steam will be represented by the path following the 1 2 2 dash 3 dash 3 double dash and 4 dash. Okay, so that's why we have written that equation again. Okay. So let us put these
मैम
values in this equation. Yes, tell me please.
मैम वो 4 डैश कर दीजिए, h3 डबल डैश माइनस h4 डैश.
Yeah, this will be the 4 days. Sorry. Yes, this will be the 4 days, right? So 1 kg of steam if it is flowing uh, and following this path. So that will be in this case it will be the 4 days. So if we are putting this um, in place of this one, we will put this h2 dash and h3 dash and h3 double dash h4 dash. Then your turbine work will be become wt is equal to h1 minus h2 plus h2 dash minus h3 dash plus here that will be the h3 double dash minus h4 dash, right? So this will be our turbine work. So let us give the name. This will be the 10, equation 10. So in this case, if you are considering 1 kg of working fluid is flowing through that cycle. So through that cycle means that cycle is 1, 2, 2 dash, 3 dash, 3 double dash, 4 dash, 5, 6, 7, 8, 9, 10 to 1. So it is the complete working cycle, and here 1 kg of working fluid is flowing. So in this case, suppose I am writing that heat release by the steam condensing from the point 2 to 2 dash is utilized to heating up this water. Then our equation will be become that is your 1 into h2 minus h2 dash is equal to your H9 minus H8. So 1 kg of fluid हो रही है और ये है आपका heat released by steam condensing, from 2 to 2 dash uh, is utilized to heat the feed water from the point 8 to 9, right? तो ये है वो equation. So similarly, we can write down for the another point. ये है आपका ये क्या कौन सा पॉइंट है आपका 3 to 3 डैश ये साइकिल कंसिडर कर रहे हैं ना 1 to 2 डैश 3 डैश 3 डबल डैश 4 डैश राइट तो यहाँ पे हम कह सकते हैं कि ये स्टीम रिलीज हो रही है हीट रिलीज बाय द स्टीम condensing from the point 3 dash to 3 double dash is utilized to heating of um, the feed water from the point 6 to 7 है ना यहाँ पे यूटिलाइज हो रही है सो ये जितना स्टीम रिलीज और हीट रिलीज कर रहा है स्टीम फ्रॉम कंडेंसिंग यहाँ से यहाँ हो रही है वो यहाँ पे हीट करने के लिए यूज हो रही है सो हियर आई कैन राइट डाउन दैट इज द 1 kg ऑफ द steam that is your H3 minus H3 double dash which is equal to your 1 into H7 माइनस H6 सो ये स्टीम हीट रिलीज हो रही है फ्रॉम द स्टीम कंडेंशन से जो कि यूटिलाइज कर रही है हीट यूटिलाइज टू इंक्रीज द टेम्परेचर ऑफ द फीड वाटर so this will be the equation so it is equal I can write down H3 minus H3 double dash is equal to your H7 minus H6 okay so let us give the equation number this is the 11 and this one is the 12 by considering these two equation and in place of your WT then I can write down what is the turbine work in this case टर्बाइन वर्क यहाँ पे कितना होगा इसको अगर हम रीअरेंज कर रहे हैं सो ये इस फॉर्मेट में पाने के लिए सो दिस विल बी H1 this equation 10 become H1 minus ये है आपका H4 डैश राइट सो यहाँ पे H2 minus H2 dash फॉर्मूले में लानी है so this will be H2 sorry minus ये माइनस है यहाँ पे प्लस होगी so this will be the minus H2 dash right so again this form will be in forms of the H3 minus H3 double dash so it will be the minus H3 dash minus H3 double dash right ये plus हो जाएगी so I have rearranged this turbine equation so which will be given in the format of the heat released by the steam condensing from the point 2 to 2 dash and steam condensing from the 3 dash to 3 double dash okay so now we can put this formula in this equation that is your H1 minus H4 dash minus here it is your in place of this I can put H9 minus H8 minus here it will be the H7 minus H6 so from this formula we can get the what is the loss in work and loss in turbine work okay so this is the regenerative cycle we can also do the combination of the reheat and regenerative cycle so this is the combination of regenerative cycle. As I've already told you, modern power plant, they are using the combination of these two, where they have used the preheater. So in that case, both the thermal efficiency and specific power output of the plant will increase. So why we are using the reheat cycle? So we are using the reheat cycle to reheat the steam in between these two turbine, high pressure and low pressure turbine, so that we can increase the pressure of the expansion process. Okay, so that we can get the maximum power output. But cycle temperature will be the that will be remain same. Okay, so I think I'll discuss it tomorrow. It will be better because we do not have the much time here. So I will share this slide to you so that you can have idea about this regenerated, how we have evaluated. I think here you do not have any doubt. I think I have cleared uh, this doubt, how this fluid is entering to the heater 1 or heater 2, and how we are writing that equations. Okay, so thank you all. Give me the attendance, Ritika.
Okay, ma'am.
Thank you, ma'am.
Thank you,
Thank
ma'am.
you. Thank
Thank you, ma'am.
Thank you, ma'am.
you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.